How to create a character configurator using React Fiber. Hi, in today's video we are going to see how to create a character creation screen. The different aspects we will cover are how to position and animate the camera based on what we want to customize, how to change material colors. This is a theme I already covered in the product configurator video, so watch this tutorial first. How to use morph targets to change facial expressions. For this tutorial I reused the model I used in the animation tutorial, but I fine-tuned it a little bit. I added some shape keys to have control over its facial expressions. You can get the starter pack from the link in the description below. Are you ready? Let's go! Camera animations. Let's start by downloading our starter pack, git clone and our project URL. Once it's done, open it in VS Code. Okay, so now yarn install to install our libraries and yarn dev to see if it's working correctly. We have our new model because the default colors are different from the previous tutorial, and we still have the animations. Perfect. The first thing we want to do is to add some buttons here like head, top and bottom to edit the pants and the shoes color. What we want to do is when we press head, it will zoom in front of the head. When we hit top, it will go slightly behind and in front of the top, and same for the shoes. The first thing we want to do is to create a new context. We have the existing one for the character animation. We will just leave it as it is and create a new one. We will name it character customization context. So const character customization context equals create context empty object. Export character customization provider equals to, we will get the children, and we will return const here, and we will return character customization context dot provider value empty for now, and we will wrap our children inside. Then a last one, which will be a use character customization. Use character customization equals to return use context from our character customization context, and we also export it. So here is our empty context. Don't forget to wrap our application inside it. So here, character customization provider, and here too. What will we need in our context? As we said, we want a camera mode. So const camera mode set camera mode equals to use state, and we will put a mode here. So let's define the different modes we want to be available. Export const camera modes. So the possible values are free, head, top, and bottom. And the default value will be camera modes dot free. Don't forget to export our camera mode and the method to update it. Perfect. Now let's go to our interface, and we will add on the top, so it will be in a different affix. Here, it will be top 50 maybe. We will fine tune later. This time we will be using a group instead of a stack. And we will display a button for every single camera mode. So camera mode dot map mode, and we will return a button. The key will be the mode. The variant will be if the mode equals to camera mode. If it's the case, it's filled. If not, it's light. And on click, let's set the camera mode to the new mode. And we are good. Well, we're not good. Inside, we should display the mode name. And we should be good, but we didn't define the camera mode and set camera mode, so we get them from our context. Use character customization, and now we should have access to them. Here we have an error because camera mode.map is not a function, which is normal because it's object.keys from camera modes because it's an object, and then we can map it. So let's reload, and we have our interface working correctly. We have free, head, top, up, bottom. Okay, so now we can choose the different camera mode. Now let's move the camera based on what we selected. Let's create a new component that we will name camera controls. Export const camera controls. Return. What we will need here is, in our experience, we will take the orbit controls and move it into our camera controls. So here, and return orbit controls. We also need to import it. And here, replace it to camera controls. So far, it shouldn't have any negative impact. The camera still works, but it's in a separate component, so we can add specific logic to it. So inside our camera controls, we will build some logic. What we will need is the current camera mode, and to be able to change it as well. I will explain to you later. Use character customization. The method we will use to move our camera based on the current selection is useFrame, which comes from React Free Fiber. So the first thing we do is, if the camera mode equals camera modes.free, we will leave the orbit controls working automatically. So just return. Then, if we have another mode, we will need to move our camera position and target. Okay, so what we want to do is to move our camera. So we have access to the camera by using state. So state.camera.position, and as we want to animate it smoothly, we will use a function which is named lerp, and we will need to define the target vector and the speed. So let's define our different camera position. Const camera positions equals to, so for the head, camera modes.head, we will use an object with the position where we will want to put our camera. New 3.vector3 will be in front, slightly above, and a bit behind, so 1. And we also need to define the target, which means what we are looking to. So it's the same, but the target is at the model position, so 0. 3 is not defined yet, so import everything as a 3 from a 3. Where do we want to lerp? We will want to lerp at camera positions of camera mode. And for the speed, we will use 1 for the moment. Let's load. So on 3, it's doing nothing. And if we press head, it's going too far away. Oh yes, we forgot to add dot position. So it's going to an undefined place. If we click on head, it directly goes into here because our target isn't set correctly to in front of us. So let's start by smoothing the animation. Here we're using 1, but it's too fast. We can have access to the delta time, so we will multiply 3 by the delta. Now, when we click head, it's way smoother. But we still have the problem because it's looking in the middle of the body instead of the head. So we need to adjust the target. To do so, we need to define to orbit controls what the target is, because by default it's a 0 in the center of the scene. So we need a reference to store it. Orbit controls, but here lowercase equals to use reference. Here let's pass it orbit controls dot current dot target dot lerp to animate it smoothly too, and we will do exactly the same. But it's not the position, it's the target. Now let's see what we have so far. It's going to the head. Now let's replicate for top and bottom. Here and here we have top and bottom. So here we will go slightly on the left just for an animation effect. But we will still target the center. Here we will put at 0.2 and here 2 as well. And as we want to zoom out a little bit, we will put to -1.5 and here we don't change. Here we go back to 0 on the x-axis. On the y-axis we will go -0.05 and we'll go still further away because we want to see the shoes and the long legs. Let's save and try. So here we have the head, the top and the bottom. You can see it's going a bit further away, and as long as we're going close to the head, the camera moved forward to it. What we want to do is to go back into free mode, so we use it by default without having to press the free button. To do this, it's really simple. On orbit controls, we will use the onStart event, which is triggered when we try to move the orbit controls. And here we will set the camera mode to free. Now let's try. We go to head, but we want to move, it automatically toggles to free. And same applies for the other as well. Colors customization. Now let's do something tedious that we already did in the previous tutorial. Now what we will want to do is create a user interface to change the different colors, like for the hair, the eyes, the glasses, the mouth, and everything we can customize. Let's go into our character customization context and create state for everything we want to change. So we have hair color, equal use state. We also have the eyes, the mouth, glasses, the skin, the shirt, the pants, the shoes, laces, and the sole. So set skin color, set shirt color, set pants color, set shoes color, set laces color, and set sole color. And don't forget to export everything here. Perfect. Now we have everything. Now let's go to our interface and create the interface when we are in a mode. So let's create a new fix. Top 50, but we will put our buttons at 20. Right, 22. And now what we will do is if the camera mode is equal to camera modes dot head, we will show our interface. So let's name it head configurator. Let's save and let's create it. Head configurator dot JSX. Inside we will use a stack which comes from Mantine. We'll add some spacing between the elements and some vertical padding. And inside we will define our controls. What we want to use is the color input. So here it's the written value of the color, but we can also use the sliders to select a color. And we will use a different version which comes with a swatch, which are defined values user can use, but they also can customize it if they want to. So let's copy it. Here import the color input. We need a label. Here we want to customize the hair. The swatches, as we don't want to copy paste every time we will define them in our hook. So copy. In our hook we will define a static value, so export const swatches colors. And we save. We can keep the default one or you can create yours. And here we use character customization, colors, swatch. And here we use swatch colors. Perfect. Now we want to be able to modify it, so we will need the hair color and set hair color. Use character customization. So the value is hair color and set and on change set hair color. Now let's see what we have. If we click on head, we have an issue because I think I forgot to import it because we created it later. We save and it's working. If we select the hair, we can change the color, but it's not impacting the hair because we didn't configure our model to react to color change. Now let's go to woman. Const hair color equals to use character customization. Where are the hair here? So instead of using the material coming from the model, we will need to define a new one. So mesh standard material. We will copy the element from the materials from the model, like the roughness or metalness. And we will apply our color, which is hair color. And we can delete it here. If we save, we reload, you can see it's white because For the moment, it's using the default hair color, which is empty. And if we change it, you can see the color is updating. Now let's try to preload the color so it's not white by default. What we can do is getting the set hair color, create a new use effect to make it happen once at the loading of the app, and set hair color to materials dot hair. But it won't work because it's not a valid string. It's color. By the way, I also forgot to use dot color, so it will never work. So we use get hex string, which return the hexadecimal from the color, but we need to add the hash. So here hash, our hex string, and it should work way better. So now the default color is correctly set and we can change it as well. Now let's replicate for all the different colors. Just let's check we didn't break everything. And let's create the different interface for the configuration. So in the head, we have the hair, the eyes, the glasses, and the skin. And the mouth. Okay, so hair, eyes, glasses, mouse, and skin. So glasses, mouth, skin. And here it's glasses color and mouth color. Okay. So now we can change the eyes, the glasses. Oh, we didn't try the swatch, but it works the same. The mouth, if we want to make a gothic style, maybe with dark hair. Skin very white, so it's Wednesday. Black, everything black, and we have our gothic. Now let's create the top and the bottom interface. Top configurator.jsx. We will go straight to the point. So here we just configure the shirt. So here it's shirt color, set shirt color, okay, and the name is top configurator, and same for the bottom. We'll copy it. It's bottom configurator. We We will also copy. I love to copy paste. So we have everything from the bottom. It's here. Paste. Here we have the pants. We also have the shoes. We have the laces. And the sole. Okay, on the top, did I label it correctly? Yes. So now in our interface, we'll close it here. Where is it? It's here. We will render the other configurator based on the mode. So for the top, we will display the top configurator. Why it doesn't find it? I will see. And the bottom. Here is defined. So here top configurator should know where it is. It's a bit weird. Okay. Maybe try to import it manually. We'll see if it's broken or not. Okay, let's save. Reload and head top. Okay, we can change it. So I don't know what happened. Bottom, we can fine tune a lot of details. So blue pants, shoes green, laces black, and a black sole too. And we still have the control, and when we move our model, it's still colored because we change really how our model and materials are. Now let's switch to the facial expressions. Facial expressions. Now it's time to animate our face. Let's go to our model to explain how it works. If we go, for example, here, we can console log an object we see on the model and you didn't pay attention to, I guess, which is named morph target dictionary and influences. So let's log both. Here you have the dictionary of the name of shape keys we have and the influences, which are the value corresponding to it. Let's see what it looks like. The first one is an object with the shape keys I defined in Blender and they're indexed in the influence array. So for the 2, it's here and the value is 0. The smile is this one and the value is 0. And when we will change those values, it will impact the shape keys. And if we increase smile, our model will smile. There are values between 0 and 1 and we can adjust them all at once. Instead of creating a state for every single shape keys, we will cheat a little. We'll go to our context. So we will create a morph target dictionary. Here we will use an array and the influences. We add it here. And let's save. Okay. Now in our woman, what we will do is here, instead of writing them, we will define them. So set morph target dictionary, morph target influences, and the set as well. So set morph target dictionary, set morph target influences. So here, set morph target dictionary, and as it's an object, we will use object.keys to get all the label. And for the influences, we will keep the array. Okay, so now we should have them available here, and oh, here influences. Okay, we should have them available in our interface. So let's go to our head here and add a new section named expression. So let's use a title from Mantine. Use a 3 to have not a too big title. And let's add our control to modify our morph targets. Let's go to Mantine and see what we have. Okay, so it's named slider. And we will use those bars to go from 0 to 1 and animate our facial expression. So here we will use morph target dictionary dot map morph target index, and let's render our item. But first, let's have it from the hook. We'll also need the morph target influences and set morph target influences. So we can use a group. Inside we have a label. We'll use some text from Mantine. And we'll display our morph targets. Yes, the key is the index. We'll also have a slider with a minimum value of 0 and a maximum of 1. We define the step to something really small so it's smooth. For the displaying value, we will use value and return math.round value multiplied by 100. The value will be morph target influences of index, and on change we'll have the new value. Now what we will need to do is morph target influences of index equal to value. Okay, let's see what we have so far. If we reload and go to the head, oh, I used group instead of stack, so it's next to one another. So let's go here and replace with a stack. Okay. So now we have the different expressions, but if we slide, it doesn't work, because what we are trying to do is to change a Three.js object, and React doesn't know we are changing it, so it doesn't re-render the component. What we can do is something completely useless, like set morph target influences equals to morph target influences. So it will recreate an object and it should work. Let's reload. And here we can slide, it works, but the label is incorrect. Oh, because I multiplied the round, so it should be that. Let's reload. And now it's working correctly. But as you can see, nothing is happening. Only glasses down work and it's completely normal. Let's see why. What we are doing is changing this object. And what is this object? Is morph target from mesh 019. But when we generate our model, what it does is creating a new morph target for every mesh. But we can use the same because it's coming from one common mesh. And yes, you can see the glasses are the first one. So what we can do is use for every one of those morph target dictionary and influences. So let's copy paste. Let's save. And now we can see her face change. Let's do it ourselves. So head, if we smile, she's smiling. If we play sad, she's sad, but we can make a bit sad and smiling at the same time. You see, it's both of them are merging and creating a new emotion. You can say she's smiling a lot, she's curious, so she slick her eyebrow like this. We can make a wink, or we can say she's sleepy and she's not curious anymore. And her glass is down because she fall asleep. And now she's running while she's sleeping. Maybe she's dreaming. Now let's add a simple but very useful feature, screenshot. Screenshot. Okay, so first thing, we will need an icon. And their icons are not from Mantine, they are from Tabular. So let's add it. Let's get it, yarn add Tabular /icons. Perfect, let's go back to our interface. And before all the button, let's add a new button with an icon. We will use the icon camera with a size of 18. And on click, we will call a method we will name take screenshot. But we are in the user interface, so we can't take screenshots from here. We need to go to the experience. So we'll just make a boolean to say we want to take a screenshot as soon as it's possible. So we'll say set screenshot to true, and we will add it to our user character customization hook. So set take screenshot. We save. Here we will add a new one, take screenshot, and set take screenshot. But first let's define them. So take screenshot and set take screenshots. By default, it's false. And now it's available. Let's see if our interface is correct. Okay, to see it, we need to restart our instance. So, okay, we have a button and we can click on it. Now let's go to experience, add a use effect. We want it to happen when the take screenshot value change. So take screenshot equals to use character customization. If take screenshot, we will create a function named screenshot. Nope. Screenshot. Okay. Now let's define our screenshot function. So we create a link. We will say it will download when we click on it, and we can name the file. Let's name it screenshot.png. Let's add href to it. Here we will use the data URL of our canvas. To access the canvas, what we need to do is const jl equals to use a 3 and get it from the state. So now we will do the link equals to jl.dom element, which is the canvas, to data URL image/png dot replace image/png with image octet stream. And we will directly click on the link we created. So it's transparent and it directly downloads the file. Now let's try what we did. Here it is, we click. You have screenshot, but it's empty, which is normal because we need to specify another option into our canvas. To the canvas jl equals to, and add the option preserve drawing buffer to true. Reload, hit the screenshot button. Here you have your transparent PNG working. It's taking the screenshot at the camera position. So let's click on head, make a smile, make a wink, and take a picture. And it doesn't work because I forgot to put the test screenshot back to false. So once it's done in our experience, let's set take screenshot to false. So now let's do it again. Let's put red hair, glasses to blue. Let's smile. Let's wink. Let's be curious. And hit the screenshot button. And now it's working and you have your screenshot. Thank you for watching, I hope you enjoyed this video. It can be a good starting point to create a video game or a new metaverse. The next video about Three.js, I don't think it will really be a tutorial. I think I will create a 3D experience about Christmas and something unique. Of course, I will give you the source code so you can see what I did and I will explain it in depth during the video. Please hit the like button if you like the video, it really helps the channel grow. And if it's not already the case and you want to follow my content, please subscribe to this channel. See you soon, bye bye.